And not a function. How do we know this one's not a function? What does it fail? Yeah, it fails the vertical line test. So if we have an xy and an x negative y, it fails the vertical line test. All right, so let's go over the basic functions and then we'll talk about how we do transformations, okay? So, our first basic function that you need to know is the constant function. This is any function that's written as f of x equals c or y equals a number without an x. An example of that could be y equals 6 or y equals -2. Okay? The domain of a constant function, because a constant function is a horizontal line, isn't it? So a constant function is a horizontal line. So if we had y equals 1, we would graph this at 1. This is the line y equals 1. That is a constant function. What is the domain of that function? Yeah, from -infinity to +infinity. What is the range of that function, though? If it is constant, how many different y values is it? It's just 1, isn't it? What is that y value? So the range is just 1, or whatever c is. Let's just do it that way. It's whatever that number is, c. What is the limit as x goes to -infinity or +infinity? What's the y value that it's reaching as it goes to negative or +infinity? It's still just that same y value, isn't it? So it's c. In this case, it would be 1. It's the only value it's ever going to be. It does not have any x-intercepts, does it? But it does have a y-intercept. The y-intercept is whatever that value is. So the y-intercept is the point 0c. What type of symmetry does this guy have? Even, odd, or none? Remember, even is it can be folded across the y-axis. Odd is it can be rotated around the origin. This obviously cannot be rotated around the origin. Can it be folded over the y-axis? Yes. So this has even symmetry. It is even. Is it continuous? Yep. It is continuous. Does it have any discontinuities? Nope. No discontinuities. Okay. And it is constant. Boom. All right. Any questions about what a constant function is? Nope. Pretty good. All right. Identity function is f of x equals x. Just x. No number in front of it. F of x equals x. In other words, if you plug in an x, you get out the same number, don't you? This is a diagonal line through 0. In other words, if we were to plot this guy and do -2, -1, 0, 1, and 2, we would get the same thing out, wouldn't we? So if this were my x, this would be my y. If we plug in -2 in that function, we get out -2. So if we plot it, it ends up looking like that, doesn't it? So this is the identity function. Same x and y. All the x, y values match. What is the domain of this function? It's got arrows on the ends. From negative to +infinity. All real numbers. What is the range of this guy up and down? Still got arrows, doesn't it? So it's what? All real numbers, right? So from -infinity to +infinity. All right, good. What is the end behavior? Because that's what the limit stuff is, isn't it? End behavior of this guy What is the end behavior? As x approaches negative infinity, what is this? As x goes this way, what is this guy doing? It's going to negative infinity, isn't it? So this is negative infinity. What is it doing as it goes to the right? Positive infinity. So this is positive infinity. Does it have an intercept? Does it have an x-intercept? Where's the x-intercept? 0. Where's the y-intercept? So they're the same in this one. So the x-intercept and the y-intercept are both at 0, 0. Is this guy odd, even, or neither? Which? Well, it's clearly not even, huh? Would it be odd? Yeah. You could take it, you could rotate it back around 180, can't you? So it's odd. Good. All right, so it's odd. Is it continuous? Yep, it's continuous. Okay. Is it bounded? No, it's completely unbounded, isn't it? So it is unbounded. Is it increasing or decreasing? It is increasing over what interval? Doesn't it go up everywhere? So what do we call that? From where to where? Guys, this thing is increasing the whole way. Negative infinity to where? Okay. All right. So that's the second type of function we need to know. We need to know the identity function and what it looks like and what its equation is, basic equation is. So we've got that. Sorry, I did. Sorry, reciprocal. Let's do reciprocal next. I beg your pardon. I think I tapped twice and didn't mean it. Reciprocal function. Reciprocal means flip over, doesn't it? So it is 1 over x. So how do we figure out what this one graphs like? If you graphed 1 over x, it would look like this. If you plotted points off of your graphing calculator, it would look like this, without that hump in it. I'm sorry. It's hard to draw a straight line sometimes on this thing. Okay? And this does include the point 1, 1, and does include the point negative 1, negative 1. Now, what is the domain of this guy? Follow it from negative infinity to where? Oh, except for one place. Where's one place where we don't have anything? 0. Do you see it? We can follow. We have x values all the way this way until we get right to here where we have a hole in it, right? It's a vertical asymptote, and then we keep going. We have values, don't we? So we have to write it just that way. Did you see how I talked about it? Okay, so from negative infinity to 0, and then from 0 to infinity. You can kind of follow your hand across as you do it. So from negative infinity to 0, and from 0 to infinity. So let's do the same thing for range. Range is from negative infinity to where? Where do we have a gap again? At 0. So from negative infinity to 0, and then from 0 to infinity. It's going to look the same, isn't it? Okay. What is the limit? As we go this way, what is this approaching? End behavior would be out here. What's the value going to look like way out here? What's the y value? End behavior is a y value. What is the y value out here, guys? 0, isn't it? Isn't this thing getting closer and closer and closer to the axis? So 0. What is the y value out here? 0. Okay, so my limits are 0 on both of those. Does this thing have an x-intercept? Does it have a y-intercept? No, it doesn't cross the x or the y-axis, does it? So intercepts it has none. What type of symmetry does it have? Can you rotate it or can you flip it? You can rotate it, so it's odd. Is it continuous? No, it is not. It is discontinuous. As a matter of fact, since it's discontinuous, what type of discontinuity does it have? Guys, it has a vertical asymptote right here, doesn't it? Yes? Has a vertical asymptote right there. So it has an infinite discontinuity at x equals 0, doesn't it? Does it have any other type of asymptotes? What other type of asymptote does it have? What about here? Doesn't it have an asymptote there? So what type of asymptote is that? Horizontal asymptote at y equals 0, correct? All right. Is this thing bounded? It keeps going up, doesn't it? Keeps going down. Is it bounded then? No, it's unbounded. Where does it increase? Where does it decrease? This thing is decreasing. You see why it's decreasing? Look, from left to right, you're going down and then down again, aren't you? So it is decreasing over the entirety of the number line, isn't it? All right, so that's a reciprocal function. Now let's look at quadratic function. Quadratic function is f of x equals x squared. So this is my quadratic function. To find this one, we simply plug in an x and a y. If we plug in -2, we get 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. If we graph those, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, right? Look what we get. We get a parabola. That is a quadratic, isn't it? Okay, so what is the domain of this guy? Caden, what's the domain of this guy? All real numbers. Good. From -infinity to infinity. What is the range of this guy? Tessa, what's the range of this guy? What's the lowest y value to the highest y value? Lowest is 0, so it goes from 0 to where? Good. The range is from 0 to infinity. Since both ends go up, let's remember, since both ends go up, what is my end behavior for both sides? Yes, thank you. Positive infinity. Goes up for both, doesn't it? All right, intercepts. Does it have an x-intercept? 0. Does it have a y-intercept? 0. Crosses the x and y axis both places at the origin. So the intercepts are 0, 0 for both. All right. Other. Is it odd, even, or neither? Good. It is even. Is it continuous? Yeah, good. Is it bounded? Be careful. Does it have a maximum or a minimum? It has a minimum, doesn't it? So it is bounded. It's bounded where? Below. Yeah, so it is bounded below. We can even talk about its concavity. This one's got concavity, doesn't it? Is this one concave up or concave down? Good. So it is concave up. All right. Is it increasing or decreasing? Both. Where does it increase? Good. From 0 to infinity. Where does it decrease? Good. From negative infinity to 0. Very nice, guys. All right. We're almost there. We've got a couple more to do, and then we'll start dealing with, you got 4 more. Cubic, square root, absolute value, and cube root. And the rest of them we're going to leave for another time. All right, cubic function is x cubed. So this is y equals x cubed. So let's actually figure out what points to plot for this guy. Do you notice I'm using the same points every time? -2, -1, 0, 1, and 2. So if you can't figure it out and not put it on your calculator, if you couldn't use your calculator, you could plug in points and figure out what it looked like, couldn't you? So -2 cubed is -8. -1 cubed is -1, 0, 1, and 8, right? So let's plot these. -2, -8 would be way down here. -1, -1, 0, 0, 1, 1, and 2, 8. So this guy is going to look like this, isn't it? All right. So now, what is the domain of this function? Does this, doesn't it? All real numbers. What is the range of this function? Since it does this, what is the range? All real numbers. As it goes to the left, what is the end behavior? Where is it going to the left? Negative infinity. And what is it doing to the right this way? Positive infinity. Good. What are the intercepts? 0 and 0, right? So 0, 0 are its intercepts. Awesome. Okay, other. Is it odd, even, or neither? It's which? Can it be rotated 180 degrees? So if it can be rotated, it's odd. All right, is it continuous? Yes, it is continuous. All right, is it bounded? Does it have a maximum or a minimum? Doesn't, does it? So it is unbounded. All right. What about increasing or decreasing? Is it increasing or decreasing? From left to right, what is the function doing? Increasing. So it's just increasing. So it is increasing from negative infinity to infinity. Now this guy has concavity, doesn't it? So where is it concave up? And where is it concave down? So where is it concave up? Where does it scoop up? 0 to infinity, right? If that's the case, then where is it concave down? Negative infinity to 0. So where is its point of inflection? Where's the halfway point? Where does it turn around? At 0. So it has a point of inflection at 0, 0. Good. All right, square root function. Square root function, we can't plug in any negatives, can we? Nope, we can't. So when we do our little table of values, we're just going to stick to positive values. So 0, what's the square root of 0? And then I'm going to pick 1, what's the square root of 1? And then I'm going to skip to 4 because I know the square root of 4 is what? 2. And then I'm going to skip to 9 because the square root of 9 is 3. So we're going to plot 0, 0, 1, 1, 4, 2, 9, 3. And this gives me enough to figure out that it looks like that, doesn't it? So what is the domain here? Where does it start? Left to right, where does it start? And goes to infinity. So the domain is 0 to infinity. Around the range, where does it start and where does it go to? Going up, 0 to infinity. If we go to the left, what's the value? What's the end behavior as it goes to the left? 0. Good. What's the end behavior as it goes to the right? Infinity. Yay. Has this helped some of you going through all of these again? Is it kind of getting it in your head? Good. Intercepts. Where's the intercepts here? X and Y are both at 0, aren't they? So 0, 0, my intercepts. Other. Does this have odd, even, or neither? Neither. It's no symmetry, right? So no symmetry. Is it continuous? Yes, it is continuous. All right, does it increase or decrease? It increases. Where does it increase? Yep. Does it have any concavity? Is it curving? Yeah, it does, doesn't it? Where's the concavity? Concave down. From where to where? It's here, isn't it? So that's from where to where? From 0 to infinity, right? Okay. Is this getting easier to see it? Oh, yeah. Is it bound? It's bound where? Below, yeah. It is bound below. Bounded below. Thank you for reminding me. This is bounded below. So let's move on to absolute value. Absolute value is absolute value of x. So how do we graph this guy? Did I skip one? Absolute value function. Absolute value function, we should know what that one looks like already, shouldn't we? This one can have negatives, so we're going to do -2, -1, 0, 1, and 2. Absolute value makes everything positive. So we have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. It looks like this, doesn't it? So now, domain. Yep. However, the range is what? Reading it, bottom to top, where does it start, where does it go? 0 to infinity. To the left and to the right, what is its bound? What is it doing? What's its end behavior? Yeah. Positive infinity, both ends are up. Intercept. 0, 0. X and Y. Symmetry. Good. Heard somebody say it. Even. Symmetry. Okay, so we've got even symmetry here. Now, is it continuous? It is continuous. All right, cool. Is it bounded? Bounded where? Okay. Bounded below. Does it have a maximum or a minimum? If it has a maximum, an absolute maximum, it's bounded above. If it was an absolute minimum, it's bounded below. And that point down there is the lowest it goes, isn't it? If its range is not, do you know how you can tell where it's bounded to? Look at its range. If its range has a lower number, that's not infinity, negative infinity, it has a lower number here, it is bounded below. If it has an upper number here instead of infinity, it's bounded above. If these are both negative and positive infinity, then guess what? It's unbounded. So you can tell right here from the range whether it's bounded above or below. Which one of those has a number? All right. Does this thing increase or decrease? Yeah. Yep. From 0 to infinity, it decreases from negative infinity to 0. Good. You got this down. All right. Does it have any discontinuities? Nope. Because it's continuous. Good. Cube root functions, the last one we're going to look at right now. Cube root function, cube root of x. This one's a little tougher. We're going x and a y. We could do negative 8. What's the cube root of negative 8? Negative 2, guys, right? Isn't negative 2 times negative 2 times negative 2 negative 8? So cube root is negative 8. Then we'll go to negative 1, 0, 1, and 8. So let's plot those points. At negative 8, it is negative 2. At negative 1, it is negative 1. Then it goes to here, and then here. So look what this guy does. Doesn't it look like you took a cubic, rotated it, and flipped it over? Think about it. Cubic does this. So now we just turned it on its side and then flipped it over, didn't we? All right, so we know what's its domain. Left to right, what's it doing? Range. Up and down, what is it doing? Not real numbers. End behavior. To the left, where's it going? To the right, where's it going? Intercepts. Have we had any other intercepts other than 0, 0 for these parent functions? That should tell you something. Other, is it continuous? It is continuous. Does it have any symmetry? Odd symmetry. All right. Is it increasing or decreasing? It is increasing. Where is it increasing? Be careful. Yep. So it's increasing from negative infinity to infinity. All right. Does it have any concavity? We've got a curve, so we need to think concavity, don't we? It's got both, doesn't it? Concave up. Concave down. Where is it concave up? Remember, up means it's like this, isn't it? Scooping up. So where is it concave up? Good. From negative infinity to 0. And where is it concave down? From 0 to infinity, which means it has a point of inflection where? Yep. Good. All right. Okay, so let's actually take and look at some of these and see if we can tell how we work these. We're going to skip all the, I think. I'm trying to see if there's anything else. Maybe we had to actually take that back. We're going to do greatest integer function because we did cover those, didn't we? Greatest integer function looks like it's a type of step function. It starts here, steps up. It is a ceiling function. Greatest integer function is a ceiling function. Remember we did those last time? You know how I know it's a ceiling function? Because the first number is closed circle and the second one is open, isn't it? So it is rising up every time. What is the domain of this function? Left to right, what are the values? Where one lets off, the next one what? Picks up, doesn't it? In other words, if you were to take all those stairs and collapse them down, would it be a solid line? So what is the domain? All real numbers. Think about it going the other way. What is the range going to be then? It is not all real numbers. It is all of the integers, isn't it? So it's just the integers. So the domain is all real numbers, but the range is just integers. What's the limit? As it's going to the left, what is it doing? Yeah, negative infinity. As it goes to the right, what's it doing? All right. Wow. Is this thing odd, even, or neither? You're going to be tempted to say it's odd. It is not odd because of that open circle, closed circle thing. So it is neither. So it has no symmetry. Is it bounded? Nope, keeps going up and down, so it is unbounded. All right, is it continuous? Oh, don't you dare say yes. What type of discontinuity does this thing have every step? You go across and then you have to do what to get to the next step? Jump. So it has an infinite number of jump discontinuities. It is a jump discontinuity to every single integer, doesn't it? So it has a jump. It is at all the integers, right? So it is discontinuous. And guys, this thing is considered to be a type of constant function. It is constant. It is not increasing or decreasing, is it? It's constant, but where it's constant is here. It is constant at every n to n plus 1. What does that mean? That means it is constant from 0, or from 0 all the way until we get to 1, but it doesn't include 1, does it? So from 0 to 1, it is now constant from 1 to 2, from 2 to 3, from 3 to 4. That's what that means. You plug in a value for n, and it gives you the boundaries for each of those little constant figure pieces, doesn't it? Okay, so that's it. Let's now talk about parent functions. Every one of these has, and you've seen this before, guys. You have seen this right here. We have never seen it this way using A, B, C, and D. You saw it this way. And if you like it better this way, you're welcome to do it this way. We used H and K, didn't we? Do you remember A, B, H, and K? When we did transformations in Algebra 1 and Algebra 2. You've done transformations a million times. H and K are left and right, right? So H and K is the indicator on the graph. A, B are real numbers. A and B are stretches and compressions, up and down, side to side. H and K are left and right and up and down, aren't they? All right, so it wants to know, how do we write this constant function? What is this constant function? How do we write a constant function? It says f of x equals c, right? And the range is y equals c. So this is what? What is this number right here? What is this guy? Where is it at? 3, right? So this is the function g of x equals 3. What is its domain? All real numbers. But what is its range? 3. Good. So now you guys try the same thing for this dude. What is it going to be the function of? H of x equals what? Good. -2. What is its domain? What is its range? See how easy this is? So now let's try this for the identity function. So we've got the identity function right here. We know that it's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. Correct? Its domain is all real numbers, and its range is all, I don't know why this says integers. This should not say integers. This should say all real numbers, shouldn't it? That was weird. All right, so let's write this guy. First thing we need to figure out is where is its, how is it moving left and right, and how is it moving up and down? If it's normally here, and now we're moving it to here, how have we moved this guy? We've moved him to the what? We moved him to the right one, and we've moved this down 2, haven't we? So this is to the right one would be -1, and down 2 would be -2 out here. The left-right, remember, goes in opposite, doesn't it? Now, this thing is supposed to go up from left to right, isn't it? It is not. It's now going down from left to right, which means instead of a positive in front, what are we going to put? A negative in front, because it is flipped over, isn't it? Now, this guy normally goes, I want you to notice something, normally goes over 1, up 1, doesn't it? This guy, however, doesn't go over 1, up 1. He goes over half, down a half, over 1 half, doesn't it? Down a half, doesn't he? In other words, over 1, down a half. That down is the negative, the half tells you what number to go in front. That tells you how much he is compressed. Does that make sense? That slope tells me. So what is the domain of this guy, though? Still, what is its range? It's not going to change the domain and range, is it? So this guy becomes the following. Y equals A x minus h plus k. That is our transformation equation. So let's see if you can figure this guy out. Normally it's here, isn't it? So we're going to start this by saying x here, and we're going to have to fill in here and here, aren't we, first? So the first thing I want you to do is say, if I had to move from 0, 0 to this point, what would I do? I would go over to what? 3 to the right and 3 to the right and down how many? So what does that 3 to the right do? -3 inside, and the 2 down does what? The 2 down and the other one went a -2 on the end, so the 2 down here also puts a -2 at the end, doesn't it? Now we got to figure out what goes in front. Normally it's supposed to do this. This one does this, doesn't it? So what automatically goes in front? A negative, right? We can tell that from the slope too. From one point to the next, how do we figure out what this guy is doing? Let's find a point here, and we got another point here, so it goes down 1, 2, 3, 4, 5, and over what? 2, right? So the slope is -5 over 2, so that's what goes here. Now, What's the domain? What's the range? Yeah, it's never going to change for a line, is it? Okay. Let's look at some for a quadratic. For a quadratic, the quadratic function goes 0, 0, it goes over 1 up 1, over 2 up 4, doesn't it? That's how we tell what it's doing if it stays its function. But also left and right. Normally it's here, correct? So I want you to look. We see what the basic statistics are for a quadratic. Normally our vertex is at 0, 0. So what do we have to do to get our vertex now to go here? We went to the left, how many spaces? 3 spaces to the left, right? And then what? Down 3 spaces? 4 spaces, right? Down 4. So how does this work? We've got to fill in here and here. The left, right goes inside. The up, down goes outside. So what does that left 3 become inside? Right was minus. So left has to be what? So it would be plus 3. Down 4 would be what at the end? Minus 4, correct? Okay. Now, normally we go over 1, up 1, correct? Isn't that what I said, over 1, up 1? So let's check that here. Over 1, up 2. So guess what goes in front here? 2. So what is the domain of this guy? If the domain is normally from negative infinity to infinity, is it going to change the domain? Nah. The range, however, has changed. Where's the bottom of this thing now? Negative 4. So the range is now from, yeah. All right. Let's try another one of these. Let's set it up. We've got x something squared. We're going to have to fill in here and here and here, aren't we? All right. So the center is normally at 0, 0. Where did we go now to get to this vertex? Yep. To the right 2 and up 3. Yep. Minus 2 plus 3. You got it. Now, normally we go over 1, up 1. This time we are going over 1, down a what? It doesn't go all the way down, does it? How far down does it go? How far down does that go? A half, maybe? Let's look. Over 1, down a, yeah, it's right at. So instead of over 1, up 1, we go over 1, down a half. So guess what goes in front here? Negative half. Okay, what's the domain? But what's the range this time? Negative infinity to where? 3. Okay. You starting to get the idea of these? A little bit, maybe? Square root function, we've only got a couple minutes left. We'll do as many of these as we can. Let's do a square root function one, and then we'll try to do an absolute value one because we're almost completely done. All right, square root function normally is at 0, 0. Now this one has moved, hasn't it? So where did this guy move to? The point 4 what? 4 negative 2, right? So now we got to do square root of x what? Right 4 means what happens underneath here? Minus 4, and then the minus 2 goes to the outside. Normally this is over 1, up 1. This one is over 1, up what? Ooh, this one doesn't work very well that way, does it? So what's happening here? This one's flipped sideways, isn't it? Not up and down. This one's flipped sideways. So guess what that means? We got to be careful here. If this one's flipped sideways and not up and down, we actually have to make room for it to have a negative in front. This one normally goes over 1, up 1, but this one actually goes over 2, up 2. So this is like over 1, 1.5. We'll have to get better at explaining this. All right, guys. You do have some homework. You need to give it your best shot. The practice problems, okay? Work on the practice problems, yep. 1-5 practice. I gave that to you. So see what you can do with it, and we will work on this more next time. All right.